In this video, we're going to study a triangle group called LR. LR stands for link ratios, high, BS. It's essentially the same triangle group, or it's part of the same triangle group that we have modeled before, LR high. For this particular triangle group, you might remember that the paid loss is cumulative. If you applied the extended link ratio family, the default model is the Mack method. These are the volume weighted averages, same thing as the Mack method, formulated as regression estimators. When you look at the residuals versus calendar year, you will notice that the residuals actually trend downwards. This means that the actual trend in the method is higher than the trend in the data. The residuals represent trending data, or the trend in the residuals represent trending data minus the trend estimated by the method. So the trend in method here must be higher than the trend in the data, since the difference in the two trends is negative. So an answer we will get is a mean reserve of 901 million, or I guess almost 902. Actually, these numbers are pretty meaningless because the method we just used has got nothing to do with the volatility, trend structure, and the data. But anyway, let's just continue for fun. So let's now use the arithmetic average. Arithmetic average is also, in fact, any ratio method. Any average ratio method can be formulated as a regression estimator. We do this forecast, we look at the logbook, we get 1.1 billion. Okay, what if instead we fit the trend N ratio? In other words, three parameters. There's an intercept, there's a trend N ratio between each two development periods on the cumulative data. And now we remove some of the early calendar years. Suppose we did that. We estimate that. We optimize twice. The resultant model, you'll see, hardly ever uses ratios. Most of the ratios equal to 1, of most of the ratios minus 1 equals 0, meaning ratios don't really have any predictive power. Now, here, for this particular method, it's a bit like a circus, but anyway, for this particular method, we can see that the trend in the data minus the trend in the method is essentially 0. So the trend in the method, or estimated by the method, is very much in keeping with the trend in the data. So the answer now should be much lower, considerably lower. The answer is now 494, which is based on the Mack method 901. It's just a little bit more than a half. Based on the arithmetic average, it's about half the answer. So here's an example when a couple of minutes, actually, in several seconds, you can actually show that the Mack method applied to this particular portfolio, its order BI, gives you answers which are almost double the reserves you should be holding. Now, if we go back to the Mack method, we run it ratio only. We're going to now bootstrap these residuals. So what are we going to do? We've got our residuals in here, but they're not really random from the same distribution. Or are they? Well, let's see. These residuals here for the late calendar years are pretty low. The ones that are below 0 are clustered together. The ones that are above 0 are kind of more sparse. They're more separated, so these are skewed distributions, but most below 0. All these residuals are larger than 0, are positive, and they're above the 0 line, so they're not random from the same distribution. These residuals come from one distribution, these residuals come from a very different distribution. So, the bootstrap technique actually only works if the method works. Now, the method doesn't work for this data, so we're going to be designing bootstrap triangles that don't look anything like the real data. So we take all these residuals, put them into a flask, select one at random, put it into that cell, put it back into the flask, select another one at random, put it in that cell to create your bootstrap triangle of residuals. Take this triangle of residuals, add it to the fitted values to create a bootstrap triangle. Let's do that 3 times. In other words, 3 bootstrap triangles. Let's save this model as the Mack method. We haven't done that yet. Just for the sake of convenience, because after all, the default model in the extended link-shell family modeling framework is the Mack method, volume-weighted averages. Let's copy that model to each of the simulated bootstrap triangles. Now let's look at Mack, Mack, Mack. Let's open these. So we highlight BS, BS1, and BS2, open these. Now tile vertically, let's open the residuals, all of them. Let's tile vertically, minimize other types. Now let's look at versus calendar year. And you can see that when you look at the bootstrap samples versus calendar year, they don't have the distinct downward trend versus calendar years, where the observations in the most recent calendar years, the positive residuals are kind of separated, they're far from each other. The negative residuals are all clustered, they're closer to each other. Over here there's kind of an even spread. Over here there's kind of an even spread, and over here also, and you don't have the distinct calendar year trends because you've reallocated the residuals, these residuals here, you've allocated to there. Some of these residuals you've been reallocated to the latest calendar years, and as a result of that, the bootstrap triangles do not have the structure, or even a similar to structure to what's in the real data. Now, if I take, say, let's close all these regression tables. If I go to BS1, which was the first triangle that we simulated, actually the first one was BS. Let's suppose we go to BS1, which is the second one. And for me to create the corresponding incremental triangle, so we'll call it for Mack. We then go to data sets, make sure we assign it the same exposure. Let's suppose we go to models. And first of all, let's run the model for the paid losses, incremental total paid losses. We regard this as an apt model. It has major calendar year shifts, but apart from having major calendar year shifts, the process variability varies by development year. The weighted standardized residuals have a normal distribution. There's no doubt about that. However, if we move and set the variance to be constant along development years, if you look at the residuals versus development years, you could see there's more spread here, perhaps more spread there, and much less spread there. So the spread of the residuals increases as you go down by development year. If you now reinstate the model, so this model actually has the trend features, which are described by development year trends, accident year trends, and calendar year trends, and calendar year trends project in the other two directions, which is an accident. But apart from that, the variance of the normal distribution varies by development year. Let's suppose we simulate 3 bootstrap samples from this model. And we copy the model to BS1, the triangle that was designed by the Mack method, the bootstrap triangle that came from the Mack method, the incremental version, and BS2. Now we grab, oh no, it's the wrong ones, we've got to go to good. Oops, BS for Mack. There seems to be one missing. Where's BS2? Maybe we didn't copy it. No, we didn't. So let's go back to BS1 and drop that model also on BS2. Fine. Let's now grab BS, BS1, BS1 for Mack, BS2, run with them. Right button of the mouse, open, tile vertically, minimize other types. You'll see essentially that for the one that comes from Mack, you don't need all these calendar year parameters. Let's check out the residuals. And let's tile vertically, minimize other types. pity they're all maximized, so I've got to do it one at a time. So you'll just have to bear with me. How about these? There's 4, there's 1 missing. BS1, PLI, BS1 for Mack, BS2. Should be a BS, shouldn't there? BS. Okay. Now, which one is different versus development years? Well, the one that's really different is this one here. This one is an outlier, so I'm going to get rid of it. Now, what's happened for this data is because it's heteroscedastic and data in the latest development years. Well, let's look at the model. Versus development years, these numbers have held much more process variability on the log scale and the percentage scale than these numbers. But using the Mack method, you didn't account for that. You've really redistributed all the numbers around the triangle, okay, when actually for the Mack method you had a trend structure, negative trend in the residuals, but also the Mack method doesn't account for the fact that the volatility in the incremental data changes by development years, so you can actually distinguish now, and you can see that the Mack method has not captured the volatility in the data, because when you look at the Bootstrap sample, the volatility versus development year is very different to the ones that were simulated and the real data. If instead we estimate, say, the SGI model, one parameter in each direction, or maybe the statistical chain ladder, to see the resultant calendar year trends to each triangle. This is just a diagnostic model. And look at each versus calendar year. Could we tell the difference? It might be a bit harder. Well, I guess the one that's most unusual in terms of the one that would stand out of these, although it's a bit hard to see, 1, 2, 3, these look very similar. They look very similar to this one, which is the real data. That one looks like the most unusual. That one looks like, it doesn't stand out that strongly, but if you just look at the volatility in these periods here in the early calendar years, that's very tight, that's pretty tight, that's pretty tight, that's pretty tight. If you remove that one, they look pretty much all alike, but yet the one designed by Mack doesn't look anything like the real data or the ones simulated from the PTF, the optimal identified PTF model. Let's just run the models through them again. Good, 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 good. It's easier to see that the Mack method has had a lot of trouble in capturing the volatility around its trend structure, apart from just the trends versus development years. So we just revised that again. Okay. Even if we remove that observation, which is an outlier, it is definitely the guy that stands out. Very difficult to reproduce features, and in fact it's impossible to reproduce features in real data using link ratio type techniques, which obviously includes the Mack method or arithmetic averages or arithmetic averages applied to the last 3-4 years and so on. You have no control on assumptions going forward. In fact, you know, if you think about it very carefully, methods based on link ratio techniques, yeah, kind of information free, aren't they? Okay, thanks for that.